And we're rolling.
All right, gang. Last section, real quick. Hopefully this won't be more than a couple minutes. Okay, so we're going to talk about sound waves traveling through in mediums other than air, and we're also going to talk about light waves a little tiny bit. So, sound waves can travel through air, obviously, and they can actually travel through any medium where compression can occur. Okay, so if a medium can be compressed, then the wave can be formed and propagate through it, all right? If the medium cannot be compressed, then it's impossible for that compression to happen, and so therefore the wave is going to stop its travel at that point. So the compressibility of a medium actually affects the speed at which the wave will move throughout it. So the easier it is for a medium to be compressed, actually the more slowly the sound will travel through it. Okay? So if it's more easily compressed, the wave's actually going to move more slowly than if it's not as easily compressed. Okay? We also have a spectrum of sound waves, some of which we can hear. The range of sound waves that we can hear is what we call the sonic, right, wave range. And that's typically the sound waves that we can hear. Those are sonic waves, and they basically vary from 20 to 20,000 hertz. Now, we have sound waves that travel above that frequency, okay? The word ultra means above or beyond. So ultrasonic would be sound waves that are above sonic or above, greater than 20,000 hertz. We also have infrasonic waves. Infra means below, beneath, or under. So obviously infrasonic are going to be waves that are below the sonic wave range, which is going to be less than 20 hertz, okay? Obviously, an ultrasound has to do with sound waves that travel at ranges above 20,000 hertz. By transmitting basically a wave of a known frequency, they can use information about the reflected amplitude of waves and the period of those waves to determine general shapes. And that's how we can see the fetus in a baby in a womb throughout pregnancy. Okay, so before we get into detailed study of physical light, which is going to take place next week, we're going to just do a little tiny bit of comparing sound waves versus light waves. And we're going to start by just looking at the speed. Now, if we use the equation 11.2 to calculate a speed of sound in air, we would get a velocity of 343 meters per second. Okay? And that's at 20 degrees Celsius. We know that temperature can affect it, but assuming you're traveling at like 68 degrees Fahrenheit, which clearly would not be happening today in Tennessee, we would have 68 degrees, maybe in my house, right? So sound waves traveling in my house right now at 68 degrees would be moving at a velocity of 343 meters per second. Again, it's a speed, not a velocity, because we're not talking about direction. So it's moving at a speed of 343 meters per second. The speed of light in air, okay, because obviously it can move through different mediums as well, but we're talking about the speed of light through air is 3.0 times 10 to the 8th meters per second. So let's do a little bit of comparing. Let's start with, and he did this in the book, so this is repeating, but I still think it's worth mentioning because it's so profound. So if you were to travel around the earth in a car, if you could do that at 60 miles per hour, it would take you 17 days to travel the circumference of the earth. If we could send sound around the circumference of the earth at its speed in air at 68 degrees, it would take, moving at 343 meters per second, it would take it a day to travel around the circumference of the earth. Okay? If we took light, which travels at 3.0 times 10 to the 8th meters per second, and shot it around the earth, the circumference of the earth, it would basically take it 0.13 seconds to travel around the circumference of the earth, which is kind of mind-blowing to me. It also tells us why you can't outrun lightning, because lightning is basically just light energy. So given that it could travel the circumference of the earth in 0.13 seconds, I'm pretty sure you're not going to be able to get away from it. So, and obviously the medium that light travels through doesn't affect it as well, but very generally speaking, as a medium becomes more dense, the light's going to travel more slowly. So that's my last little segment. Thanks for listening. Have a great week. I missed seeing your faces today, and I look forward to seeing some of you throughout the week as we do warrior stuff, and the rest of you next Tuesday. Have a great week.